Dear students, now we are going to another topic deals with the norms and the traces. What is the norms? So, for alpha following k be the given number field, then the norm of alpha or the norm is denoted as nk of alpha. It is denoted as nk of alpha, or simply it is n of alpha. This is norm. This is a notation of norm. For n alpha is present in k, where k is the number field, then the norm is denoted by nk of alpha or n of alpha, and is defined as this n of alpha equals product I ranges from 1 to n sigma I of alpha. Product I ranges from 1 to n sigma I of alpha. Similarly, the trace, this is norm, and the trace is, this is norm, and the trace is denoted by tk of alpha, or simply it is t of alpha. So it is given by t of alpha equals sigma I ranges from 1 to n, capital sigma. Sigma I ranges from 1 to n sigma I of alpha. So this is the norm and trace. N of alpha is product I ranges from 1 to n sigma I of alpha, and trace of alpha is sigma I ranges from 1 to n sigma I of alpha, where alpha is alpha presents in where the number field k itself. And we know that what is the field polynomial? The field polynomial again in terms of sigma I of alpha. It is denoted by f alpha of t equals product I ranges from 1 to n. It is t minus sigma I of alpha. So this is the field polynomial. So the norm, trace and field polynomial of alpha, which depends upon this sigma I of alpha. In terms of, that are defined in terms of sigma I of alpha. This is norm of alpha, trace of alpha, and sigma I of alpha. Suppose alpha is an integer. If alpha fall in set, then clearly if alpha is an integer, we know that the sigma I of alpha is a rational number. So clearly finally this n of alpha and t of alpha are rational integers. If alpha is an integer, then clearly this trace of alpha and the norm of alpha and the trace of alpha are rational integers. That are the crucial points. Rational integers. We know what is rational integers. So can you say that this norm is multiplicative? We know what is n. Norm of alpha is simply product I ranges from 1 to n sigma I of alpha. Okay. So in order to prove, so consider this n of alpha beta. What is n of alpha beta? It is product I ranges from 1 to n sigma I of alpha beta. But we know that it is product I of 1 to n sigma I of alpha beta is nothing but sigma I alpha into sigma I beta. Why? Because sigma I is multiplicative. So this can be rewritten as it is product I ranges from 1 to n sigma I alpha into product I ranges from 1 to n sigma I beta. What is this one? This is nothing but n of alpha into n of beta. So the norm is always multiplicative. That is n of alpha beta equals n of alpha into n of beta. For alpha differs from 0. Clearly when alpha is non-zero, its norm is also non-zero. When alpha is non-zero, then the norm is also non-zero. That is clear from its definition. And now we are going to the trace, property of a trace. Let P and Q are rational numbers. P and Q fall in Q. Then what about the trace of P alpha plus Q beta? Trace of P alpha plus Q beta is, as by definition, what is trace of alpha? For alpha fall in K, T alpha equals sigma I ranges from 1 to n sigma I of alpha. So here for alpha and beta fall in K and P and Q are the rational numbers, then T of P alpha plus Q beta is sigma I ranges from 1 to n sigma I of P alpha plus Q beta. Sigma I of P alpha plus Q beta. So that is nothing but sigma I ranges from 1 to n sigma I of P alpha plus sigma I of P beta. Sigma I of P alpha and sigma I of P beta. So that can be rewrite as sigma I ranges from 1 to n sigma I of P alpha plus again sigma I ranges from 1 to n sigma I of P beta. So that means it is P into sigma I ranges from 1 to n sigma I of alpha plus it is Q into sigma I ranges from 1 to n sigma I of beta. What is actually this one? This is this is P of T alpha plus Q into T beta. So that is the linearity. T of P alpha plus P beta, where alpha and beta presents in K, P and Q are in Q, then T of P alpha plus Q beta is nothing but P of T alpha plus Q of T beta. Agreed? Now, suppose if K equals Q root 7, K equals Q root 7, then the max sigma I are given by sigma I. Sigma I is defined as sigma I of P plus Q root 7 equals sigma I of P plus Q root 7 is P plus Q root 7. So it is not sigma I, it is sigma 1. And the sigma 2 of P plus Q root 7 equals P minus Q root 7. Sigma 1 and sigma 2 are defined as in this way. Sigma 1 of P plus Q root 7 is P plus Q root 7 and sigma 2 of P plus Q root 7 is P minus Q root 7. And so what about n of this P plus Q root 7? N of P plus Q root 7 is nothing but it is product I ranges from 1 to n sigma I of P plus Q root 7. Okay. That is here I ranges from 1 to 2. Why? Because sigma 1 and sigma 2 are defined. That is sigma 1 of P plus Q root 7 into sigma 2 of P plus Q root 7. What is the one? Which is P plus Q root 7. P plus Q root 7 into the second one is P minus Q root 7 equals A plus B into A minus B. It is A square minus B square. That is P square minus 7Q square. What about its trace? What is trace of P plus Q root? Yes. Trace of P plus Q root 7. Trace of P plus Q root 7 is, it is by definition, it is sigma I ranges from 1 to 2. Sigma I of P plus Q root 7. Okay. That is nothing but sigma 1 of P plus root 7 plus sigma 2 of P plus Q root 7. The one is, we know that it is P plus Q root 7. Sigma 1 of that one is P plus Q root 7 and the second one is P minus Q root 7. So we get it is 2P. So that norm of P plus Q root 7 is it is P square minus 7Q square, but its trace is 2P. Agreed. So this is the method to find the norm and the trace. Now here there is an important theorem. The theorem states that let K equals Q theta. K equals Q theta be a number field. This is a number field. K equals Q theta be a number field. Theta has a minimal polynomial. P be the minimal polynomial for theta of degree n. P be the minimal polynomial for theta of degree n. then the q basis, 1 theta theta square etc. theta to the power n minus 1, this is the q basis, has discriminant delta 1 theta etc. theta to the power n minus 1 equals 1 theta theta square etc. theta to the power n minus 1 equals minus 1 power n into 1 power n into n minus 1 by 2 minus 1 to the power n into n minus 1 by 2 into norm of dp theta. Norm of dp theta. What is dp? This is a new term. dp means it is nothing but the formal derivative of p. What is dp? dp means it is with respect to d by dp. This is the formal derivative of p. So dp is the formal derivative of p. How to prove this one? So it's proves. We know that. What is the discriminant of 1 theta theta square etc. theta to the power n minus 1? We know that this discriminant is by van der Monde determinant. It is product I ranges from 1 to n, or 1 less than or equals I, less than or equals j, less than or equals n, theta I minus theta j whole square. This is from the, because we know that the van der Monde determinant, by using that idea, it is discriminant of 1 theta theta square etc. theta to the power n minus 1 is product I and j ranges from 1 to n with them, product theta I minus theta j whole square. We know that what is theta I? Theta i's are conjugates of theta. Theta 1, theta 2 etc. Theta n are conjugates of theta 1, theta 2 etc. theta n are conjugates of theta. Now, what is p of t? We know that p be the minimal polynomial of theta of degree n. So p of t equals some minimal polynomial for theta of degree n. If p of p be the minimal polynomial for theta of degree 1, then p of t is t minus theta. Okay, but p be the minimal polynomial for theta degree n, and the theta 1, theta 2 etc. theta n are conjugates of this theta, then this p of t is nothing but product I ranges from 1 to n, it is t minus theta I. Why? Because p be the minimal polynomial for theta of degree n, and theta 1, theta 2 etc. theta n are the conjugates of theta. Hence p of t can be described as it is product I ranges from 1 to n, t minus theta I. So what about its derivative dp of t? dp of t means it is sigma I ranges from 1 to n of products I differs from j, sigma dpt equals sigma j ranges from 1 to n, products I differs from j, and I varies from 1 to n of t minus theta I. Okay. Suppose it is t minus theta I ranges from 1 to 3. If p be a minimal polynomial of theta for degree 3, so what is p of t? That is p of t is t minus theta 1 into t minus theta 2 into t minus theta 3. So what is its polynomial? Its formal derivative dpt with respect to t. So it is t minus first two function t minus theta 1 into t minus theta 2 plus next t minus theta 1 into t minus theta 3 plus t minus theta 3 2 into t minus theta 3. Okay, with respect to t, you can derive that function p of t with respect to t means so dpt equals that one. Okay, plus etc. Plus, so like that, d of pt equals sigma j ranges from 1 to n, products I ranges from 1 to n with I differs from j, one term is t minus theta I. So what is dp theta j? Here dp theta j is simply it is products I differs from, I ranges from 1 to n, where I ranges from 1 to n with I differs from j of theta j minus theta I. Okay, when dp theta j, Don't be replace this t with the theta j. That is not the method. Here dp t equals this one, but dp theta j, when p of theta j is theta j minus theta I. So what is d of p theta 1? Like this. What is p of theta j? What is p of theta j? Product I ranges from 1 to n, theta j minus theta I. So what is p of theta 1? P of theta 1 means it is product I ranges from 1 to n, theta 1 minus theta I. Okay, that is it is theta 1 minus theta, where I differs from j. I differs from j. So it is theta 1 minus theta 2 into theta 1 minus theta 3 into etc. Okay, so what is it? dp theta 1? dp theta 1 is only that. So clearly this dp theta j equals product I differs from, I ranges from 1 to n with I differs from j, theta j minus theta I. So multiplying all of these equations for j equals 1, 2, 3 etc. to n, you can multiply this one. So what is the left side? Left side is product j ranges from 1 to n, dp theta j equals, come to the right side. Right side is product I ranges from 1 to n with I and j. I differs from j of theta j minus theta I. Okay, or theta I minus theta j. Here dp theta j, product dp theta j is, what is this one? This is nothing but, this is the n, this n dp theta, that is n dp theta. The product j ranges from 1 to n, dp theta j is nothing but the norm of dp theta. What is norm? It is sigma I of alpha. What is sigma I of alpha? It is alpha I. Okay. So norm dp, norm n of product j ranges from 1 to n, dp theta j is n of dp theta, norm of dp theta. And in this, in the right side, it is each factor theta j minus theta I. For I less than j differs from j, or I less than j appears twice. This term repeats twice. Okay, with where one is theta j minus theta I and the other is theta I minus theta j. Clear? When it is dp theta 1, it is theta 1 minus theta 2, and after that there is a theta 2 minus theta 1 also. So like that, here the term repeats twice, as one is theta j minus theta I and the other is theta I minus theta j. So it is theta I minus theta j into theta j minus theta I can be rewrite as minus 1 of theta I minus theta j whole square. Agreed? So like this, on multiplying this right side, on multiplying this, we get delta multiplied by this delta. This is a delta that is multiplied by minus 1 power s. What is s? S be the number of pairs ordered pair I and j given by s equals n into n minus 1 divided by 2. Number of pairs. How many pairs are there? I, j. Such pairs, there are n minus 1 pairs. So it is n into n minus, sorry, s n instead of n into n plus 1 by 2. There is n minus such a, then s is nothing but n into n minus 1 by 2. So that is our result. Delta of 1 theta, theta square, here we start from here, and this is minus 1 to the power n into n minus 1 by 2, and this is nothing but n dp theta. That is the norm. Okay.